or... Okay, so we're going to do an AngryBurds thing here. And this is the sheet right here. There he is. So now we're just basically going to combine. This is kind of a fun sheet to do just because we're trying to make it fun. And AngryBurds are always thrown up and over in a parabolic curve, which we know is a quadratic equation. So every time they fly in different quadratic equations, so they're going to change things. And what we want to do is we want to write these things in standard format, which is 3 blanks format, however you want to call it, like that. And so of these 3 blanks, the most important 3 blanks are this one and this one. And so what I'm going to do is I'm going to give you different AngryBurds here in different formats, and we just have to put it each equation into standard format like that. Okay, so let's start off with the first one here, and we'll do, I've got like 6 or 7 or 8 of these things, so we're only going to do one right now, and then we'll just, figure it out, okay? So here's Redbird's flight. It starts off at 0, goes all the way up here to 24, so this is said to be a maximum right there. What would that coordinate be? Now this one might be a little bit harder to read, but the maximum number there would be, let's see here, I'm going to draw a line across. And let's be, what is halfway between 18 and 12? Well, halfway is an average, right? 18 plus 12 divided by 2, that's exactly 15. So that's 15 high. So in other words, the max, because it's going up, is equal to 15. Well, yeah, that's great, but the most important part is the vertex. What's the vertex of that then? Well, we already said it's 15, so we know the max is 15. What's the x value? Well, that's pretty easy too, if you just write it all the way down here. What's that number? Well, 0 and 24, half of 24 is 12. So we have 2/3 of our answer just by looking on the graph and figuring out where the vertex is. Now this one is a little bit harder because there's no graph lines and you have to kind of read the y and the x. It's not that bad. Okay, so in other words, we can go up here and we can put in 12 and 15 up here in these blanks, 12 and 15, and it's positive 15 and positive 12, but then because it's going into brackets, we have to put the negative there. And we are 2/3 of the way done. Now, how do you fit the first blank in there? The first blank is A, and that is my vertical stretch factor. That's the skinny fatness factor. Do you think this is skinnier than normal or fatter than normal, just by looking at it? I think it's a little bit fatter, so this is probably, so I'm going to say fat. One thing I don't really know the fatness factor, or the skinny factor, but I do know that it's upside down, and so my answer up here is going to be negative something, right? And from a graph, that's basically all we can say. Okay, we can't really come up with a number because what we would normally do is we count over 1 and down 1, and we come up. But this graph is not that accurate, so we can't come up with a pattern that way. But I don't know if you noticed, I did it on purpose. I said the word pattern on purpose because our calculator can figure out patterns. And so let's just write down a few numbers here as a pattern. We already know 3 numbers here. So this is a nice graph. It's actually quite accurate, quite smooth and stuff. And we know that this point is on the x and the y. We know that we have 12 and 15. 12 and 15. And to make a graph absolutely perfect, when I ask you to graph them, I want 5 points. But they actually have that point, the vertex, the most important point. But they have 2 other points. 1 point's down here, because they tell us what it is. It's 0. So 1 point is 0, 0. What's one other point that they have on this graph that we can actually put into our table? Right here, right? So is it 0, 24 or 24, 0? This one is easy because they're both 0. But this one here, so when we read, it's always x first, then y. So when we read in English, we always read across, and then we go down, and then we read across from left to right, and then down, and then cross. So we read across first, so it's 24, 0. It's always x first, and then the y. This is always x, this is always y. It never changes. Okay? So 24, we got 3 points. Can our calculator figure out a pattern with 3 points? Absolutely. Let's see what we can do. So this is where I'm using my little formula sheet here. So stat edit. Stat edit, and then put your x and y values into L1 and L2, and then stat calculate 5 quadrig, and then see what happens. And then we can graph it if we want. So I got 3 numbers here, so I'm going to go stat edit. And I already have some numbers in there, but I'm just going to wipe them out. 12, 0, and 24. Nice and easy. 15, 0, and 0. Okay? Now, I go stat, scroll over to calculate, down to number 5, quadratic regression, hit enter twice, and is my r squared equal 1? Yes. So this is a perfect fit. Now, it's not so perfect in that the a value is some weird messed up number here. But it works, okay? So this is why we have to go over 1 and down 0.104166667 or something. Okay, so it's a weird answer, but it is an answer, and so I'm going to write that down here. A is equal to negative, which makes sense because we knew is opening down, negative 0.1041666 repeating. Okay, repeating. And there we are. We have 3 numbers. We have now put it into standard form. We got the a value, which is a weird number. We had to have the calculator help us with that. And we had the vertex, no problem. And we're done. So I'm going to write up, so this is the full value of a. I'm going to write up a short form 0.104 up there. And the equation number 1 is done. So Redbird, there's the Redbird's equation. I'm going to call it y1 because later on we're going to graph them on our calculator. And see some different things. Let's try Yellowbird. Have you guys seen the movie? The Angry Birds movie? No, you haven't seen the Angry Birds movie? I got to show you a clip at some point with this guy. The Yellowbird, he's hilarious, man. He's fast, and so he's zooming this way and that way and everything else. He's like a road runner, but that's like dating myself. That's way back when too. But he's got a funny characteristic there where he gets stopped by the police for going too fast, and then so he takes his revenge while the police is filling out the ticket. Have you seen that? No, yeah, okay. I got to show you that clip. It's just funny. Like so maybe if I have some time, I'll just look up that clip on YouTube. Oh, hey, we got a pattern. Okay, let's figure out if we can figure out this pattern, because there's so many numbers here. Let's see if we can figure out this pattern on our own without actually punching in the calculator. But the easy way is punch in the calculator, and we got the equation. Done. Okay, but let's take a look here. The x is 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. That's easy. Okay, let's take a look here. It's going up. It's going up. It's going up. Up, 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 down. So what is the biggest number here? 36, okay? And what's on each side of 36? It's a 35 here and a 35 here. Okay, well, if I go 1, 2 steps away and 1, 2 steps, what do you think that number will be? 32. And then what's the next number going to be? 27. So it is a pattern, and we were able to figure it out without our calculator. Look at that. Now, the biggest point, or the biggest number here is 32, 35, 36, and then 35. So this number right here is the biggest number. Well, the biggest number has a special name. We call that the maximum. And the maximum is also, since all the Angry Birds, they go up and then come back down, the maximum, there's our maximum. So we got 2/3 of our answer by just circling, right, there's your x, here's your y. And so in standard format, this will be y2, of course. We got blank, blank, blank. We got the x, which is 18, and the y, which is 36. And it's plus 36 and minus 18 because I put it in the brackets. The only thing we have to figure out is a again. And we can do the same trick there with a that we did with the Redbird, with the Yellowbird, because we have a calculator. And we got a table of values. We don't actually even have to make up the table of values. We got that. We can plug it in and see what the a is. Now, for real-world questions, the A value is often some weird number, like this is. Like, it's a decimal number. It doesn't work out evenly because it's a trajectory. Okay. In word problem questions, sometimes it works out evenly. Or math questions in the textbook, it works out evenly because I want you to be able to graph it by hand really quickly. But how do you do this? Well, let's plug in some numbers. How many numbers do you have to plug in? You need to plug in a minimum of 3 numbers. You can put it in 4 or 5, or you can put them all in, but you need a minimum of 3, and then if r squared is equal to 1, you're good to go. So let's do this again. Stat, edit, and I'm going to do 12, 13, 14. So 12, 13, 14, and on the other side I got 0, 11, 12. 0, 11, 12, oh, 20, sorry, not 12. 20. 0, 11, 20, okay. I'll do one more. 15 and 27. Okay, as long as you have to have the x values, so if I didn't put the 27 in, it's going to give me an error saying, hey, there's a mismatch here somewhere. So you always need an xy, 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 otherwise you can't figure out the pattern. Stat, scroll over to calculate, down to number 5, quad reg, and let's make sure r squared equals 1. Bingo. Awesome. Now, this tells us the answer, and same thing in the AngryBurds question. This is in the calculator's preferred format, which is general format, ABC format. ABC format is not really helpful for us when we don't know the vertex or the maximum. So we're putting it in a standard format because we're visual and we can see it that way. But the calculator prefers it this way. All we care about is the A, because the A is the same. And so A is -1. And we know it's a perfect fit because r squared equals 1. If r squared is not equal to 1, check your numbers because you just probably had a typo. So let's actually just simulate that. Instead of putting 11, I'll put 12 in there. So that's a typo. Now when I scroll over and try to do quad reg, it says, oh, r is equal to some weird, it's not 1. It's close, but it's not 1. And so that changes all my answers at that point. So just make sure that you put it in right. And there's why yellow birds. Let's do bluebirds. Bluebird is a word problem type thing. And so he starts his flight. So I'm going to kind of have to draw an AngryBurds thing here. He starts this point from 6. So there's 0. 1, 2, 3, 4, 5, 6, 0. He goes up. Ooh, and down, and goes kersplash. He lands at 26, 0. So this is 6, 0. So this is kind of like the same thing we have up here. And his maximum up there, his maximum height is 22 in the air. 22 equals max. Okay? So this one is going to be very similar to the redbird. So the easiest, how we did the redbird is we put an x and a y, and we got 2 points, 6, 0, 26, 0. We need one more point, and that point is up there. That's the most important point of all. And what numbers go up at the very, very, very top? Well, we know that one of the numbers here is 22, right? So that will be, how did we do it up here? The maximum is 15. 15 is right there. It's on the y. The maximum is always the y. So it's 22. And how far along the little thing here are we? Well, we're halfway in between. Halfway in between what? 6 and 26. So what's halfway between 6 and 26? Well, whenever you want to find a halfway point, we call it the average. So 6 plus 26, 2 numbers, divided by 2. This is 16. And so if I go all the way up there, that is 16 and 22. Now, that's really important for us because that is the vertex. And with the vertex, we've got 2/3 of the answer right off the bat. And so I'm going to write it down here. Y3 in this case is equal to blank, blank, blank. So this is now 16 and 22. And it's positive 22, that's positive, so when I put it into brackets, it's negative. And the only thing I have to do is the A value, and again, we've got 3 numbers, stat, edit, put those 3 numbers in, 6, 26, and 16. So we're really leveraging our calculator here and figuring out well, A values anyways, but figuring out the vertex and figuring out the equation for these things. So 6, 26, 16, 0, 0, 22. Stats, scroll over to calculate down to number 5. Make sure r squared is equal to 1. It is. And the b and the c value aren't going to really matter. Okay? We want to know the a value, which is negative, which means it's opening down, which makes sense, and it's negative 0.22. So I can write that in, negative 0.22. So fat skinny factor, if you take a look here, negative 0.22 versus negative 0.10 versus negative 1. They're all negative, so they're all opening up and going down. There's a normal sized one. This one is extra wide, so he's stretched out. He goes further. And this one's even stretched out even more. It's a smaller fraction, so it's going even further. So in other words, Yellowbird's going to land closer, and Yellowbird's going to land really close because it's 1, and Redbird is going to land a little bit further away. Okay. Redbird here is going to land the furthest away because it's the smallest. So, and then Bluebird is going to land somewhere over here. Yellowbird will land somewhere over there. So basically, it goes by increasing a. It tells you how tall, how skinny your thing is. We'll graph them all on the calculator all at the same time in a little bit in a second here, because we want to figure out the idea behind AngryBurds. If you haven't played it, it's a free app. Is to knock off these pigs, knock off this pig, and they are located at a certain spot, and we'll figure that out here in a second. Okay. The last one is Blackbird's flight path can be modeled by the quadratic equation that. Well, what format is that in? That's in general format. Okay. So in general format, well, that's the calculator's preferred format. And so, yes, normally we would have to put this in standard format if we were going to graph it, but if the calculator is going to graph it, we don't have to do anything at all. It's only when we want to graph it do we need to put it in standard format. We do know that the a value is negative 1, okay? And we also know, and I don't know if you recall, but the c value, which is the very last number there, that's where it crosses the y line. So it crosses at negative 39. So it starts kind of like here, and it goes down, and down here at negative 39. So it's way down, okay? That's where your quadratic will cross. But we're not going to be worrying about that right now. All we want to know is, can we graph these things on our calculator? And the answer is yes. So we put it in y1 here, normal, y2 in standard form, y3 in standard form. This is in general form. This is going to be y4, but I don't really need to do anything with it because my calculator will accept general form or standard form when it graphs. So let's just leave it there. The question didn't say convert them all to standard form. The question just said to figure out if the king pig or the mustache pig is going to get knocked from his perch, and which one does it. So here's how we're going to do. We're just going to put these y1, y2, y3, and y4 into the calculator, and I'm going to try to make it nice and pretty here, where I'm going to, make the red bird in red and make the yellow bird in yellow and blue and black. So how do you do that? Y equals. What's the y1 equation? It is red, and it's so I'm going to change the color here to red. Now, of course, you don't need to change. Where is red? There it is. You don't need to change anything, but I'm just trying to make it nice and pretty. And I'm going to put in equals negative 0.104 16666. And then I'm going to put bracket x minus 12, bracket all squared, and then plus 15. So I'm just going to put them all in. Yellowbird. Now, yellow doesn't show up well on the screen, so I'm going to use green instead of yellow. But let's just, here it is. Or maybe orange. I'll use orange, because that should show up. And the Yellowbird's equation is negative 1. So negative 1, bracket, x minus 18, all squared, plus 36. Get rid of all that extra junk. And then Bluebird, that's all I got blue. Bluebird's equation is negative 0.22, bracket, x minus 16, bracket all squared, plus 22. And finally, Blackbird, just as, I didn't have to do anything, negative x squared plus 16x minus 39. There it is. And I can go on. I can do 10 birds at once, but we're only going to do 4 of them. Okay? Now, the one thing before, I can hit graph now, but chances are it's not going to show anything. So I have to figure out what, it's not going to show anything properly because I got mine set to standard graph. Right? Zoom 6, so it's negative 10, 10. But AngryBurds, they don't do anything. Like, we only need the top coordinate, quadrant number 1, right? So anything from 0 and up and 0 and up. We don't need anything over here, over here, over here for AngryBurds. So I'm going to have to set my window. And the window I'm going to set, they actually tell me some of the windows here. It goes from 0 to 24 and 0 up to 18. And I know I've got a maximum over here of 22 and a maximum here of 36. Okay? So I'm going to make this go up to about 40. And I'm going to make this one go up to about 24, 26. Okay? And then how do I do that? I hit the window. And so the x minimum is going to be 0. And the x maximum, so the x maximum is going to be, I'm going to make mine 30. And we'll see. If it's not the right one, then that's fine. The scale should be 1, that's fine. The y minimum is 0 again, because I'm going to start off with 0 and go all the way up to 40. The maximum is 40. And the scale, we'll leave it as 1. If we can change it afterwards. We've got them all into y equals, so I'm going to hit graph. And this is what it looks like. There's Redbird, he's flying around. That's what this one looks like. Boom. There's the maximum. And then there's Yellowbird, boom. And there's Bluebird, boom. And finally Blackbird. We got all 4 on the screen. They look beautiful. And we just have to figure out where and who. Where is Mustache Pig and where's King Pig? And who gets knocked by these guys? So I'm going to do it visually here. I'm going to zoom in on this calculator a little bit. And we want to go to 2220. Whoop. So here we are zooming in. You can't really do this on your screen, but on your calculator, but I'll show you a different way. 22, so we go over 22. Now, you can count them. 20, 22, and up by 20, which is about halfway. So I'm going to guess that it's kind of blue. If I were to count, no, I didn't count. So 2, 4, 6, 8, I go up to 26, so it's up here somewhere. Somewhere up here, 20, 22. So I would guess blue. It might be orange. Okay. You can actually use your arrow key here if you want, and this actually makes it a little bit easier because it tells you your x and y coordinates. So all I do is hit the arrow key, and we want to go up. That's probably an easier way of doing it. 20. What did I say? 22, 20. So 20 going down to 20 roughly, and 22 is this way. There it is. 22, 20. There it is. That's close. That's 2120. X, a little bit less than that. No, a little bit more than that. 22 point something and 20 point something. So there's my little X. X marks the spot. And so which bird knocks off King Pig at 2220? Well, that is the Yellowbird. So I can say Yellowbird. You can't see that. Here, Yellowbird. Now, there's an easier way of doing that. Okay, so I just use my arrow key to figure it out. And matter of fact, let's do it again here with Mustache Pig just to show you how you do it. I still have my graphs on there. Mustache Pig's at 11, 16. So I'm just going to scroll over here. I'll zoom in here. I'm going to scroll over using my arrow keys to, what did I say, 11 and 16. X is 11 and 11.7, as close to 11 as I can. There, 11.02. And Y is 16. Oh my goodness, they're right close. Y is 16. So there's like a whole bunch of them. There's black and blue, it looks like. Okay? Black and blue kind of going over that. So I needed 11 exactly and 16 exactly because one of them might just touch it and one of them might, So how do you do that? So that's black and blue. So using your arrow keys like that's probably not very accurate. So let's use the actual numbers. Okay? Let's just look up 22 and see what the values of yellow, blue, black, and red are. How do you do that? There's a table feature right here. So here's how you do it. Second function table. And you'll notice that there's black numbers. That's your X. You got your Y1 numbers, which is your red bird, your yellow bird, your blue bird, and your black bird. And all we do is we look up number 22. So I scroll up. Oops, wrong way. Scroll down to 22, and we'll read the values of each of these birds and see which one actually hits. A direct hit. So we want, what, 22 I said? 22. So red bird's way out. 22 for red bird. He's at position 4.5. Yellow bird's exactly at 20, and we already knew that. Okay. Blue bird's at 14, and black bird's at negative 171. So he's way out. So it's yellow bird, and that's what we had said. Yellow bird. He's a bang on direct hit. The other one was a little bit trickier. It was 11. So let's go up to 11. There's 11. And we said it's either black or blue. Well, red's way off there. Here, I'll zoom in on this. Red's way off. Orange is off. And black and blue, you got blue is 16.5 and black is 16. Which is the one that actually hits? Black. It's pretty close, but blue is actually 16.5. The real answer then would be blackbird. Blackbird hits it. And that's how you do an Angry Bird sheet. Now, this is basically, we did this, okay? I just did it right on the sheet. So the back side of this, you don't have to worry about. But essentially, if I give you a table of values, can you give me the standard form? Yes. If I give you a graph, can you give me a standard form? Yes. If I give you an equation like this, do I need to give you a standard form? No. You can figure it out. Okay? There's only one other thing that we could do, and if I give you a word problem or like tell you the answers here, can we figure it out? Yes. Okay? The only thing that I haven't told you how to do yet is if I give you this in general format, can we put this into standard format? Okay? And we will do that here right now, but I'm going to show you on Thursday, our next class, we're going to be doing that on a more regular basis. So how do you go from general format to standard format? Why would you have to do that? Well, maybe because the question asks you, okay? But the calculator doesn't care. It can graph blackbird this way or the other way. But let's just do it anyways. What is standard format? Well, it's blank, blank, blank format, right? A, H, K. And since we already, since we already have general format, we already know one of these blanks, but we don't know the most important part of that blank. And so the most important part is the vertex. So we'll come up with a vertex here in a second, but we can fill in the A part. The number in front of that x squared is always the A, and so that's negative 1 in this case. How do you figure out the vertex? Well, here's how you figure out the vertex. Okay? First of all, you have to plug it into your calculator and then let the calculator figure it out. Okay? Now, there's two ways of putting it into your calculator. I'm going to show you both ways, and then we'll go from there. First way is we put it into our calculator into the y equals. So I have to kind of clear this out. Clear, clear, clear. Oops. So I'm just clearing out my yellow birds, and I'm going to put it into y1, just because that's the first one there. And I'm going to negative x squared plus 16x minus 39. And once it's in there, I'm going to hit graph. And we already know it's going to work. There's my graph. And so the point that we're trying to find is this point up here. Now, we could use this arrow key here, but we already figured out that it's not quite exact, because when we were trying to figure out black and blue birds, okay, it wasn't exact. But if you were to guess at the exactness there, we got 7.95 and 24.6. If you were to guess an exact vertex there, I would guess 8 and 25. Is that reasonable? Just based upon, I just use my arrow keys there, and I'm trying to, 8 and 25, that's probably bang on. Okay? Well, using the arrow keys like that is not exact. Let's let the calculator figure out the exact based upon its calculations. All right? It can take a sampling and figure it out. Here's how you do it. Once you have the equation into y equals, you can go second function, and up here, right beside the table, right up here you have calculate, second function calculate, and we want to find, we got some words here, minimum and maximum. So this graph right here is referred to as a maximum. So if it opens down, then we have a maximum. If it opens up, then we have a minimum. So we're just going to go second function calculate. Hey, calculator, tell me what the maximum is. And it says, okay, fine, but you have to give me a little hint here. You have to give me the direction because I got a whole screen to figure out. I'm not going to, where on the screen is the curve that you want? And so using your arrow keys now, you have to kind of narrow down your values. So you see a little X there? It's on the red line. And this is kind of important here because if you don't do it right, you're not going to get the right answer. So it's saying left bound down here. So what you have to do is you kind of have to tell it roughly where to shoot. It's going to make a guess. So you have to shoot it to the left, you have to shoot it to the right, and then you have to give it your best shot. So so this is the part that we want. So left of that part of the vertex, I'm going to pick a number there. Now anywhere here will work, but you want it kind of close. I hit enter. This is okay, there, I'm going to start there, and where do I want to end? I'm going to go to the right bound. And so you see you put a little line up there. Okay, so then I'm going to hit enter again. And it says, okay, where do you think, where's your best shot? Where do you think it's going to be? And then we go up to the top. So we put a dot on the left, we put a dot on the right, and the calculator is going to kind of figure it out by a process of trial and error, really, where that special vertex is, in this case the maximum. And so you hit enter and it says, oh, okay, well, according to me, my maximum was 8 and 25, which was our guesstimate too. And so, boom, 8 and 25 is the vertex for that right there. And now, oops, let me zoom out of that a little bit. And this V goes on the outside. V for vertex, 8 and 25. And so 8 and 25, of course this is plus 25, and this is going to be minus 8 because it's going inside the brackets. And there we are. It's in general form. You graph it, then you do left bound, right bound, and you figure it out. Now, here you go. Those steps, they're on your formula sheet. You put it into y equals. Then you go second function trace, which is calculate. And then you select the max or the min, depending what it is, and then you left bound, right bound it, and get your vertex. We'll be practicing on Thursday, but I wanted to give you a little heads up on that. Okay? Now, there's two ways of doing it. There's the first way. Here's the second way. Some people prefer the second way. The second way will take about 30 seconds to figure it out. Okay? There's the first number, there's the second number, there's the third number. We call that A, B, and C. A is -1, B is plus 16, and C is -39. Okay? So 3 numbers, all in order, always x squared first, then x, then -39. And if you want to figure out another way, there's a program on your calculator called Quad 3. So you hit program, go down to Quad 3, and it's made by this guy here. He's from Texas, I believe. And what you do is you go through, and you will get used to this. You enter A value, -1. You enter B value, 16. You enter C value, -39. And it says a whole bunch of different things. You press enter, and we want to go to what's referred to as the turning point. In Texas, they call the vertex the turning point because it turns around. And so we go to number 5. It says the turning point's 8 and 25. So what do? Well, you go program Quad 3. You let John Rick help you. Your turning point is equal to vertex and decimal equals roots. We're going to be using this John Rick program in a little bit. But essentially, you put it into ABC. You type in the A. You type in the B. You type in the C. These are roots, but we'll talk about those later. And you go down to the turning point, number 5, and it tells you the answer. You go on to the next question. So it's going to be really fast. You're going to like John Rick, except trying to get out of his program. It's kind of a pain to get out of his program. Okay? So we've done one AngryBurds, and I think we'll do some more there on Thursday. We're going to be using both Quad 3 and the left bound, right bound kind of technique. But again, both of those things are on your formula sheet. We've done patterns now. We've done left bound and right bound to find the vertex, and same thing, we've done Quad 3 to find the vertex. We still have to do roots, and there's a few other things to do with quadratics, but we're rounding the bend here. We've only got a few more things left to do. All right.